It's now my honor to introduce our second keynote speaker, Shaifali Puri, who is Executive Director of an organization called Scientists Without Borders. She has some pretty incredible and intimidating credentials. Not only does she hold a law degree from Stanford University and a bachelor's degree from Princeton, but Shaifali is also at the forefront of mobilizing and linking science-based initiatives to help people around the world, and particularly in developing countries. Prior to joining Scientists Without Borders, Shaifali was the senior advisor to the president and chief operating officer at the Empire State Development Corporation in New York City. That's the economic and development arm of the state of New York. So Shaifali, please join us on stage.
Ooh, thank you, Christine. All right, get on stage.
Thank you all so much. It is really such an honor to be included in a conversation like this, and I'm very excited for the dialogue and from what you will hear from all the speakers today. This is something I spend a lot of time thinking about.
And what I wanted to talk to you about today, I think, really flows a lot from what you just heard from Andrew. What Andrew just described so beautifully and eloquently were the cost curves and the technology curves. Thank you. The cost and technology curves that are changing the game of science today. It's my theory that they're changing the game of science today. And they're changing it in a way that I think is actually very profound. It's a move towards an open kind of science. The proliferation of connection technology and the reduced costs of basic kinds of lab technologies have enabled vastly many more people around the world, not only to connect with each other around science, but to do the kind of science that previously would have required expensive labs, closed and proprietary environments. And this, I argue, is as profound as the technological innovations themselves. The cultural transformation in the idea of how science is to be practiced, how the knowledge and the dissemination of scientific knowledge should be spread, and how it should be used. And that's what I want to talk to you about today. So how do we see this happening in the world today? Well, many of you have probably heard about crowdsourcing and citizen science, efforts to do things like catalog the stars in the cosmos, solve complicated math problems, catalog the plant diversity, are really rapidly accelerated by the access that millions and millions of users around the world have to the internet and to the ability to connect with each other and transmit information back. But it's also happening in other ways that are, I think, actually more profound for human discovery and for tackling our planet's global challenges, which is what I think about every single day. My organization, Scientists Without Borders, provides a free web-based platform to connect scientists and related actors around the world to share resources, share insights, and share innovations. So this is happening, this idea of using web-based platforms and connection technologies is something that now we have a third of the population's planet has access to the internet. There's 6 billion mobile subscriptions on the planet. So we're talking about basically a massive force of intellectual capital that can be brought to solving these problems. But well, as fascinating as I think the crowdsourcing is, and as much as we hear about that, and we like to hear about the stories of lots of people being able to catalog the stars much faster or solve complicated math problems, what I'm really fascinated about is the emerging ethos that is also coming along with this technology and with the innovations that are reducing the cost and with the connection. So let me give you an example. Last year, in the fall of 2012, 3 Dutch recent university graduates won a prize from Vodafone, and they announced that they had invented a mechanism for testing for malaria that could test many, many, many more strands at much cheaper cost and much faster than all of the existing and standard protocols for testing malaria. So these 3 young, freshly minted university students, all students of very esoteric fields like bioinformatics and cell biology, had really been fascinated. Why was it the case that some of the technologies they knew existed could not be applied to a problem as basic as malaria, which kills an untold number of people in the developing world and has massive, massive development consequences. So they started looking at a technology called PCR. related to all of the things that Andrew was just telling you about. And they said, well, how could we connect PCR technology to mobile devices? Because we know that healthcare workers in low resource settings really are very dependent on mobile devices because they don't have health clinics. And wouldn't it be great if you could rapidly test for a whole set of strains of malaria, if you could transmit that information quickly back to a hospital, and you could do rapid, in-field, real-time diagnostic tests with results? So the PCR technology that they relied upon, a commercial PCR machine, can run anywhere up to about $30,000. But luckily for these three scientists, and luckily for us, and luckily for the sufferers of malaria, an open PCR kit, full with protocols and standards, can be found on the internet. You can go online, you all, I suggest, should go do it, and find your protocols and specifications for creating your own PCR kit. Using parts that are readily available online, you can build it for an estimated $600. Well, these three scientists, these three young Dutch scientists, built their open PCR kit for about $60. And so with that $60 kit, and they were able to innovate to connect the mobile technology, they built a prototype of a machine that they think will cost about $250 when deployed in field. The cost, of course, of prototyping the machine, of meeting the regulatory requirements, of getting to even a pilot stage will be about $1.5 million. But imagine, $1.5 million to build a medical diagnostic tool that they did essentially and completely on a backbone of open protocol, open knowledge, open dissemination. And when asked, when they won this prize, if they intended to get a patent on the machine, they said, one of the scientists interviewed said, "We don't really see patents as fitting with our mission. In fact, we kind of think maybe you should ditch the whole patent approach." All right. So maybe we're not going to ditch the whole patent approach. Maybe that's an extreme response. Maybe it sits at the margin. But what these scientists demonstrate is that along with the technology that they used and could access, they are part of an ethos, an emerging, crystallizing ethos that values the notion of open, that values the notion of democratic dissemination of the knowledge, and that is not necessarily motivated by the traditional and rigid notions of IP structure, and IP protection in what they are trying to do. Why does that matter? It matters because science evolves with the scientists that it is producing. And these young scientists exemplify, they are the new vanguard of a class of essentially digital natives, people who have grown up in an environment in which knowledge, whether that knowledge is cultural production like music and movies, or open source computing and software, as again Andrew so eloquently described to you, has been predicated in a way that for them suggests that it shouldn't be locked behind closed doors in labs, it shouldn't be sitting behind walled gardens. So any institutional actor that is going to think about the future of science, is going to think about the future of innovation in science, is going to have to think about the culture, the philosophy, and the mindset of these young scientists who are going to be the future of science. So what does that mean for the kind of conversation that we want to have about open? What does that mean for institutions and traditional actors? It's pretty clearly the case that institutional science today and large-scale institutions are not being completely threatened or displaced by this open science movement, this DIY bio type movement, the kind of wet lab that Andrew described to you, which by the way is in my neighborhood in Brooklyn, but is also in Indonesia, in Kenya, in India, in MIT, and in Caltech. It's happening, it's proliferating, and it's global. Well, what it means is that institutions themselves are going to have to respond to and embrace these notions of how to be more open, how to consider thinking about their IP structure in a way that is less calcified and less rigid, because while they are not facing a threat of extinction anytime soon, and while there will always be a need for these repositories of massive scientific knowledge in big institutions with the resources that they bring and their own wealth of intellectual capital, the revolution that's happening at the margins is rapidly encroaching on that calcified center. So what does it mean to think about this model of open, this model of IP in new ways? How do we do that? I would argue that that's not a technology. That's not going to be driven by a technology. That is a cultural shift, and that is a mindset shift. That is something that is going to take viewing IP not from a traditionally defensive posture, not from as something that is either scarce or can be reduced in its value by being encroached upon, but rather seeing potentially these stores of intellectual property, the wealth of intellectual knowledge generated on a daily basis in the labs of major multilateral corporations and massive universities is actually a source of potential untapped value. That the institutions that are going to thrive are the ones that see themselves as not only possessing the value that inheres in their intellectual property that they're already aware of, but that actually values the global network of expertise that they have not yet asked to mix their own knowledge, their own resources, and their own unique insights with that existing quantified body of value. We've seen that this can actually bring beneficial results. This is not just speculation, and it's not just Pollyanna thinking. We see institutions that have opened up their IP to innovation or gone outside of their closed R&D networks, their traditional networks, whether that's through open innovation incentive prizes or whether that's through IP in patent pools, starting to realize that, as Bill Joy, the very famous technologist, once said, the smartest people do not work for you. The smartest people for your company often are located outside of your company. So we ourselves, for example, have worked with a number of big institutional partners to help them think this way and to sort of change their notion about IP in the space of global development and major global challenges. I'll give you an example of a few of the things that we have done. We became very focused on tackling the problem of maternal malnutrition, and specifically micronutrient deficiencies among women of childbearing age in the developing world. Micronutrient deficiencies actually have been deemed by a number of multilateral stakeholders as probably the greatest, investing in combating micronutrient deficiencies has been identified as probably one of the greatest returns on investment you can make for your global development dollar. Seems like a very simple problem, and yet there are not very many good interventions. So we started looking at women of childbearing age in the developing world and infant mortality and realized that one of the very basic needs was a better way to get folic acid to women of childbearing age in the developing world. It's something that we who live in the developed world don't even think about because so many of our basic foods are fortified with folic acid. This is not the case in many of the poorest regions of the world, and they're not very good local sources of folic acid. So we went to our partner, Pepsi, and we said, you know, what if we convened the world's leading experts on maternal malnutrition, and what if we really asked them to identify the innovation gaps and the innovation barriers? Why is it the case that still today, if you want to give a woman who is lacking folic acid a supplement, she has to take a small, medicinal-looking, bad-smelling, bad-tasting pill? And we know, just like we ourselves in the developed world, that if something tastes bad, it's not something we do in our normal daily course of existence, it's hard to do, we won't do it. Didn't seem like rocket science, didn't seem like it needed the kind of innovation that would enable you to sequence DNA on a USB port drive. So we said to Pepsi, why don't you put up a prize and we'll convene the experts, and then we'll go out and disseminate this as an open innovation challenge, the kind of thing that Syngenta has done, the kind of thing that you now see companies doing all the time. We held open our contest for 30 days, and in 30 days, we reached about 300,000 people. We got over 60 submissions of ideas for better ways to get folic acid to women of childbearing age in the developing world, and a third of those ideas came from the developing world themselves. Now, that in and of itself is interesting, but you've probably heard of this many, many times. The X Prize does this, and like I said, many companies do this. But what we said to Pepsi is we said, first of all, this isn't about Pepsi and their product line. This is about actually trying to make a basic seed of knowledge available to as many people as possible so that you can innovate on top of that basic seed of knowledge. So what we're going to do is we're just going to publish openly the solutions that we pick as the winning solutions that are independent panel picks, and we're just going to publish them on our website, and we're going to make a call to action to as many innovators as possible. We put up the prize, we did the mechanism to find the innovation, and now you can take this ball and you can run with it. Anybody, anywhere. If you're Coke, you can take this ball and run with it. If you're one of the brilliant students at MIT, you can take this ball and run with it. If you're one of the brilliant students in a wet lab, in a community lab, trying to solve your own problems in Kenya, you can take this ball and run with it. Now, when we first proffered this idea, people said, you must be crazy. Why would Pepsi do that? Why would they just put up the money and go out there and not say that we have the exclusive rights, especially if the idea is interesting, which, by the way, the first place idea was interesting. It was an idea to triple fortify salt with folic acid and other essential vitamins. Something that's also sort of core in Pepsi's business. They probably wouldn't love for me to say it here, but I think they use a lot of salt, and they're always looking for better salt. Well, the reason, on one hand, you could say is corporate social responsibility, altruism. That's probably true, and it's also not a bad reason. But on the other hand, is in the course of talking with us about what we were really trying to do, it became clear to Pepsi as well that it was better for them if this solution was published openly. And it was not just better for us, but it was better for them. Why? Because the more people who were able to take the seed of an idea about how you might triple fortify salt, the more actors there were investing resources, that meant that Pepsi wasn't the sole actor or the sole partner that we were turning to bear the risk. It meant that a lot of those innovations that we put out there and said do this openly could also be fed back into a 360-degree feedback loop, which was better for them as well as they were thinking about these kinds of innovations on a daily basis. Is it the case that our idea to triple fortify salt with folic acid is going to dramatically change the way Pepsi does its salt science? Probably not. But is it the case that it actually received interest from multiple different labs, that multiple people who had not thought about the problem of women of childbearing age not having adequate access to folic acid, nor had thought about how they might start to tackle that problem, suddenly not only started to think about that problem, but started emailing us and saying, well, have you thought about microencapsulation techniques? And I have a newer way of doing that that might be cheaper. That was precisely what happened. So that's from the example of us tackling a global development challenge or taking a CSR approach. We are not the only people starting to experiment in this space. One of the most interesting initiatives like this that I have come across recently and have been in conversation with is something called SAGE Bionetworks, which is headquartered out of the Fred Hutchinson Cancer Research Center in California. What SAGE is trying to do is SAGE is trying to tackle the problem of drug development, of how expensive it is, of how long it takes, and they're trying to do it in a way that leverages these open science techniques, and they're also trying to do it by acknowledging that the rapid acceleration and insight is not just going to come from scientific breakthroughs, from finding the right molecule, but from all of the cultural changes that we are talking about. So how are they doing that? Well, SAGE was started by the former head of oncology research at Merck, so someone who came out of a large-scale institution who understands fully and completely the intricacies of intellectual property and the drug development process, who also understood that taking a drug to market costs billions and millions of dollars and takes lots of time, and was frustrated when he realized that as a scientist with Merck, just like at any other pharma company, when he was going out there and trying to innovate, he was making ultimately one bet. He was betting on one approach, and it was going to take him and his team and every other team working on every other vertical of drug years and years and years to figure out whether or not their approach was going to work. And it didn't make any sense. It didn't make any sense to the process of trying to alleviate major health conditions taking millions of lives. It didn't make a lot of sense from a resource perspective. So he went out and started SAGE, which is a not-for-profit. He raised $30 million to do that, so chump change in the scheme of drug development. And then he went out and in disease areas like Alzheimer's, Huntington's, they're talking in cancer as well, convinced major pharmaceutical companies to start sharing their data sets and to put them in an open pool of data, which patient data could be deposited and could also be taken out. So many of these drug companies were running trials and clinical trials, and he kept hearing over and over again, well, we have a certain population of patients, but we need many, many more. It would help us figure out much more quickly whether or not these drugs were ultimately going to be efficacious. Said, well, why not collaborate? Why not put them in a data pool? And everyone told him he was crazy, that they would never agree, these companies. So he recognized that it wasn't the science that was the problem. It wasn't the science that was the impediment. It was the governance. It was, how do we actually create the cultural conditions of practicing science that would motivate and incentivize these scientists and researchers to actually want to do this? So what SAGE is doing that's so interesting is, in addition to just creating a platform, and they have a very interesting platform called Synapse, in which you can put a lot of this information, they are also concurrently developing portable information, portable privacy and privacy frameworks for patients that would be portable, so that you don't have to go and reinvent the wheel on privacy frameworks. You don't have to go and reinvent the wheel on data sharing frameworks. They're basically trying to create what I would call the open infrastructure that is necessary to actually implement open, shared, collaborative innovation in the sciences. So they also have a Congress every year that brings all of the actors together to say, what are the governance issues? What are the geography issues? How can we collectively actually think about transforming not just the actual mechanisms and tools, not just putting everything online, but how do we actually think about getting actors, all of the actors who are going to need to act in this space, to feel comfortable with acting in this space, addressing the human dimension of innovation. Something that is absolutely critical and what we see in the work that we do across multiple areas of great need. The one piece of connective tissue between our work in maternal malnutrition, in clean water, in sustainability, in HIV, in malaria, is that most often the barriers that we come across are ones that are attitude barriers, human culture barriers, and the culture of the practice of science barriers. So we see SAGE, and we see some of the things that we're trying to do is models, and many of the people who you're going to hear from, as starting to posit these models out there that can actually give us some of what I would call the constitution that is needed for innovation. And I don't want to be overly Pollyanna-ish about this too. So I want to say that this is actually incredibly, incredibly hard. It has taken SAGE probably about 5 years to come up with some of the basic frameworks, and a lot of resources and a lot of time. Clearly, we know from studies of distributed innovation, which is what all of this is, that the two key things are, how do you reduce the transaction costs of doing the innovation, right? So the transaction costs are things like litigation over IP. And how do you basically increase the access? Those are the things that make innovation in a distributed system happen. These things, reducing transaction costs, are going to require players that are not just unilateral. That makes them hard to do, but it makes it incredibly necessary to do. Increasing access, on the other hand, is something that institutions can actually think about in the way that was described earlier, that Syngenta has done with its own IP. I'll give you a wonderful example that somebody gave me recently that I hadn't really thought about the web, but it really crystallized it. Many of you may recall in the early days of the internet that two of the biggest service providers, access providers for the internet, were AOL and a company called Prodigy. You might remember those good old dial-up days, or You've Got Mail days. Well, why don't AOL and Prodigy exist as the dominant forces on the internet anymore? Well, one reason is because when AOL and Prodigy were in business, they were focused on paid access to the internet. So the innovations that you see on free access to the web, the whole host of computer-generated businesses, part of that was because the resources of innovation didn't have to pay for access to basic spine and structure. They could devote resources to, the innovators could devote resources to actual innovation. What is the thing the web enables that didn't exist before? So in this context, I think it is incredibly important for all repositories and holders of IP, of proprietary IP, to think about that when they think about innovation. Reducing transaction costs will be a collective effort. Increasing access may be something that is a space in which it can be done without needing to mobilize multiple other actors in quite the same way. But that's, again, going to require somewhat of a leap into the unknown, into the sort of untested waters. But it is not an excuse, I think, that it's going to be difficult, that it's going to be difficult to figure out how you navigate multiple geographies, multiple different rules of engagement, multiple different ways in which distributed innovation does or doesn't work. It's not going to be an excuse to shy away from it or from the hard work of doing it, because the fact is that, as Andrew has demonstrated, as we see every day, open is not something that we can ward off. Open is coming. Many of you might have heard last week about one of the young kind of pioneers of the internet and the open internet who committed suicide. He was being prosecuted, Aaron Swartz, for having allegedly, illegally downloaded millions and millions and millions of documents that he thought should be in the public domain, because they were research studies funded by public dollars, and to him it seemed wrong. So the question, but I'm interested in not the question of whether he was in fact right or did something illegal. What I'm interested in is that after he killed himself, the outrage, not just about whether or not he should have been prosecuted, but a collective movement by many of those researchers whose documents he had illegally downloaded to tweet and to post on Facebook the articles themselves, saying knowledge is something that wants to be free. It is a public good. We all know in this room that the answer is much, much more complicated than that intellectual property matters. It is incredibly real. It's not a regime that's going to change, nor is it a regime that should change, because certain aspects of intellectual property protection have actually motivated a lot of innovation. But we know that the culture and the ethos of science and scientists is moving towards open access, open practice, open dissemination, open protocols, open knowledge. And so what I would want to leave you with today is to say that complexity cannot be a barrier for those of us who are going to stay ahead of the curve, and those of us who see it not just as an intellectual imperative, but also as a moral imperative. Because if we are going to feed 9 billion people by 2050, we have to take into account that currently we have close to 3 billion people online, 6 billion subscriptions to mobile phones. That number doubled, the 3 billion, close to 3 billion online. That number, in the last 5 years, that's doubled from 1.5 million to 3 billion. So we know in the next 5 years, even more people are coming online. So we have an intellectual imperative and we have a moral imperative to figure out how we're going to catalyze the resources, the knowledge, and the expertise of all of those people to solve the challenge of feeding 9 billion people. And complexity is not going to be an excuse for not doing it. So I would suggest here that we go ahead and get ahead of the curve and make complexity actually our call to action as to why we must do it. So thank you, and I look forward to the rest of the conversation.